Hi guys, I hope you're doing okay. This, hard to believe, but is our final lesson of this year. Crazy. And final lesson, but we've still got a few classes to review for that final test. So let's jump right in. Not a long lesson. This is kind of in conjunction with last lesson, which was all about arithmetic series. This one's about geometric series. So if we fill this little blank in, it says geometric series is the sum of the first n terms of a geometric sequence. And so the same thing we did with an arithmetic sequence, we can do with a geometric sequence, which is add all of the terms up. The derivation of the formula is a bit trickier to go through, but I've provided it here. If you want to go through it, feel free to. You're not required to. But basically, what I need you to have and be aware of is this is the formula for the sum of n number of terms for a geometric sequence, where the ratio between terms is not 1. Otherwise, it would just be a repeating constant for terms. So some of the applications for this are interesting. And one of the things is what's called a pyramid scheme or a Ponzi scheme. Ponzi scheme's named after the guy who first did this apparently in about 100 years ago, 1919, trying to dupe money from people. And I think Bernie Madoff was doing something like this. You may have heard of his name. He was taking billions of dollars from people. Basically, you've got a scam where people input money or items and they're told they will gain a certain number of times back their money. So only if they sign up more people. And sometimes you got to sign up like 6 people, 10 people, 4 people. It depends on the situation. But the problem is it doesn't take long to exceed an unrealistic number of people. And what we're going to look at here in one example is how many people would you be needed to sign up if you signed up 4 people and then they had to sign up 4 people and this kept going for 12 rounds. So the best person to explain this is probably Michael Scott. So I might get a copyright infringement for this one, but so my suspicions were correct. I can't show that video. I just got copyrighted. I tried to upload it onto YouTube and it won't allow me. So if you can, I'm going to put this link. I'd like you to watch this little clip because I think it's funny. And it relates to what we're doing. If we were in class, we would watch it together. So I'll just post this link on our Edsby page and you can watch it at this point in the video and then come back to our video. So just press pause, go over to Edsby. Okay. Let me just get back here. So you can see this is the type of thing. We've got this pyramid. Basically, it doesn't take long before you run out of people to sign up, or at least within the people you know. And so generally the people at the top make a bit of money, but as you peter down to the bottom, you end up not getting anything if you're near the bottom and people just lose the money. So the math behind this. So let's say in this example, the one signing up 4 people and then they signed up 4 people. What we have is some sort of exponential function. So we start as 1 person and you get 4 people. So you add 4, they get 4 people. So we add another 16 and then it keeps going timesing by 4 each time. So that's what makes it geometric sequence. And what we're going to look at is for this one, how many people would we need if you went 12 terms? So A in this case is 1, R is obviously our common ratio of 4, and N is the number of turns that we're going to do where we do 12 rounds of signing people up. So if we take that formula we just saw above, we get this. One thing to watch out for here is that what you've got is the -1 is not with the exponent. So just watch out. This is just exponent n. And the 1 is by itself. So if we sub this in, this one's not too bad. So I've got the sum of 12 terms in this sequence. A is just 1. R is 4. And so we can plug that all in. And if you do this properly, so I would do the 4 to the exponent 12, enter, and then -1, and then divided by 3. What you get is 5,592,405. So what that means is that you would need a total number of over 5 million people to sign up in 12 rounds. So the pyramid that I've got here, basically they're signing up 6 each time. And so round 1, they've started with 6, but it doesn't take long until you actually exceed the population of the whole world. And so in these Ponzi schemes or pyramid schemes, basically they peter out rather quickly. So one of the things you can do with these sum of geometric series. So in this one here, I'm going to we're just going to practice using that formula. So it says determine S of n and then the 13th term for each of these. So let's write down what we know. So A is the first term, which is 7. And then R, and if you see what R is, you don't have to go through this process, but I'm going to write it out anyway. I'm going to do T2 over T1, which should be equal to the next sequence, which is T3 over T2. So let's write those values in. And so this one comes out to -3, and if you do 63 divided by -21, you also get -3. So that is my ratio. And then in this case, we're looking for the sum of the 13th terms. And so we can sub in that for n. So let's take our formula. I'll just write it out again. So the sum of 13 terms, sub everything in. Make sure you keep your -3 in brackets. And so I'm going to populate here from my calculator just to show you how I might do this in terms of order of operations. But basically this is going to come out to, and this is where it gets tricky with the negatives. This -3 to the exponent 13 remains negative, but because we end up with also a negative in the denominator, the negative in the numerator divided by the negative in the denominator, it gives us a positive value. So I would always double check that, because if you make a mistake on your calculator, it's less. Put in here what I would have done on the calculator. Hopefully you can see this. But basically I would do everything with starting with the exponent stuff. So -3 to the 13. And then just make sure you press right on your calculator, because otherwise it will do 13 minus 1 in the exponent. So you want to have this -1 outside. And then so that takes care of that part within the upper brackets. And then you press enter, you get that number. And then everything can be done all together because it's that number times 7. So that takes care of the 7. And then you do the -3 minus 1. Obviously you need to know that that's -4. And then so you just do divided by -4 and you'll get your answer. So we'll try that with the next one as well. So this one, if you want, you can try this yourself. I think the tricky part here is just getting the R value. So this is where you really want to use your ratio of terms. Again, I'm going to do it with 2 sets of consecutive terms. So T2 over T1, so that becomes 108 over 162. And that should be equal to 72 over 108. And so if you simplify that, you should get an R value in both cases of 2/3. In the rare case that it's not the same, that means that you do not have a geometric sequence. But obviously in this case, we're going to. The other thing here, we've got n's, the same thing as the previous question, which is 13. So let's sub this all in. So 162 for my A. R is 2/3, exponent 13 minus 1 within the bracket. And then I've got this weird thing where I've got the fraction in the denominator. So if we simplify this slightly, so I've got 2/3 to the 13. I'm going to leave the top like that, but 2/3 minus 1 ends up being minus or -1/3. So Now, again, what I would do, and I'll highlight it here, is I would start in the brackets here to the exponent and do that on my calculator, then -1. So you get an answer, and then same thing, multiply by 162, and then divide by, make sure you put it in brackets, that -1/3, and we end up with 483.5 approximately. So the sum of 13 terms. So again, a bit tricky on the calculator, but should be able to get it. I would test that out and you can check what you got here. Okay, one more question, then you can try a bunch on your own. So this one's where we are given a bunch of terms, but we don't know the last term number. We know the value of it, but we don't know which number in the sequence it is. So when you look at this one, it's pretty obvious each time we're multiplying by, it looks like -3. So I've got my A value. My R is -3. I don't know the number of terms, but I know that the nth term is 3,645. So I can use our T sub n formula. So just a reminder, it looks like this. Sub everything in. And we're trying to isolate for the thing in the exponent. So our variable's in the exponent. So I move everything I can over. So I divide by 5 on both sides. So that gives me 729 on the left side and -3 to the exponent n -1. So again, this is where if we could do logarithms, we would do it, but we can just do a little guess and check. And it only takes, 10, 20 seconds. So what I want is the same base on each side. So I must make 729 base -3 to some exponent. I'm going to put a question mark to represent that. So over on the side, I'm going to do -3 in brackets, and I just punch in things. And I honestly, generally, you're going to get pretty close, if not exactly. This one works out to exponent 6. So -3 to the exponent 6 equals -3 to the exponent n -1. So once we have the same base, we can drop the exponents. So in this case, n is 7. So now we can take our sum formula and sub everything in. So 5, -3 to exponent 7. And if you want, you can punch that all in, but I'll just do it in a couple steps. Again, we're going to end up with a negative divided by a negative. So the sum of 7 terms in this case is 2,735. And we're done. So not too bad. You can try the U-try part. It's pretty similar. I'll just scroll onto that page, and then if you want, you can pause the video. So, congratulations, you finished the final lesson of grade 11 functions and the end of distance education, at least of new material. It's awesome. Unfortunately, you still have a few more classes and a final test, but just be aware we have now finished all the material. That's great. So, congratulations to you. And let me know if you have any questions whatsoever. See ya.